Welcome back. In this installment, we will look at the single responsibility principle with Python code examples. Let's dive in. Welcome back. Let's have a look right now at Solid Principles of Object-Oriented Programming, a practice session. In this session, we're going to look at an exercise for you for single responsibility principle, which we also call simply SRP. All right, so let's have a look at this piece of code. We have a simple class, which is a to-do list. We have an initialization where we initialize the tasks that are part of the to-do list. And then we have a number of methods. We have obviously an add task. We can delete a task. We can display all the tasks right now in our to-do list. We can also input a task, which is where the user basically enters the actual task themselves. And then we also have remove a task, where the user can specify the task that is going to be removed. Okay, so this particular class violates the single responsibility principle. What I would like you to do is basically just have a look at it, think about it, pause the video, because what I'm going to do next is I'm going to give you some hints about it. So I'm going to show you the hints right now. Again, if you want to, pause the video. So here are the hints. First of all, notice that the to-do list class handles multiple responsibilities. It handles managing tasks, it handles handling user input, and it also handles displaying the tasks. So those are really three completely different tasks. This violates the SRP, which states that a class should have only one reason to change, or one responsibility. Basically, having multiple responsibilities in a single class makes the code harder to maintain, harder to understand, and much harder to extend, because changes in one area might impact other areas. All right, so next we're going to look at the actual solution. So what we're going to do is we're going to refactor this to-do list around those three areas. So if you want to pause the video, please do so, but otherwise I'm going to take you to the solution. So here now, we're going to have our class broken up. So we're going to have a task manager, which is going to only manage the aspect of working with tasks. In other words, you can add task and you can delete a task. And it also manages the list of tasks. That's it. Next, we have a class called task presenter. That's the one that is going to deal with outputting. So we have a display tasks. We're making it a static method because it itself, it does not hold the variable of tasks. It will just be given the tasks. And then we also have a final class, which is task input. This class manages the user input. So in this case, we'll have a static method, which is going to simply ask the user for a task. And then we're going to have a remove task method, which is simply going to remove the task. So in the refactored solution, we have now three separate classes. We have task manager, task presenter, and task input. The task manager handles the storage and management of tasks. Task presenter displays the tasks. And task input handles the user input for adding or removing tasks. This solution, this refactoring, adheres to the SRP principle as each class now has a single responsibility, making the code more maintainable and easier to understand. All right, so I hope you enjoyed this little practice session. So I'll see you in the next video. Do have a look at the examples of SRP in other languages such as Java and Dart in this playlist, as they will give you more exposure to this important principle. In the next installments, we'll be looking at the open-closed principle. See you soon. Don't forget to hit the subscribe button, give us a thumbs up, and ring the bell to get notified about our latest content. Thanks for watching.